Hello and welcome back to this Manufacturing Systems Technology module 45. We were discussing about the Toyota production system and some of its components, and we mentioned that it is different than the American system, the MRP, material requirement planning based system, which is more a push based system. So let us today in this lecture first try to have a schematic lookout on what really we mean by pull and push systems. Okay, so here you can see there are different processes in a particular assembly or sub-assembly of a product, and at the end there is finished product here, but it goes through process 1, 2 and 3, and there is a flow, continuous flow of raw materials from one side which leads to the different processes and finally gives the finished product information. So there are two different kind of lines that you can see. One is the solid line here and there is another dotted line. The solid line actually means the production flow, and the dotted line means the information flow. Okay, so basically what happens is that in this kind of, and this is called a push based system because this system is governed by a certain plan which has been made for a time horizon for looking at the market, looking at the the customer aspirations and wants, and probably the marketing has suggested that so much product of a certain type X can be absorbed by the market. So over a period of, let's say, 15 days or 10 days or maybe even 30 days. So there is a planning horizon which is there, and the marketing has suggested these requirements, and based on that now all the subsystem level requirements are generated, or all the small components which would typically go into sub-assemblies, which would again modularly go into the final assembly, they are generated. So this generation is spread as a production plan all across the whole organization with its various departments and divisions making different modules towards the final product. And then because of this plan there is a requirement assessment and there is a material buying or inventory buying which formulates all the way to the vendor, and now this material has a lead time aspect. It comes in and now it is ready for the production to begin. So once this has happened, the material as well as this information is forward pushed from the raw material stage to process 1. Now what are the problems associated with such a push based system? That's why it's called push based. So you're pushing the material from in a forward direction all the way to the finished products. Now supposing there is some snag in the process 2 which happens, because of which the process 2 stops producing the particular component at this particular level. Okay, so if the process 2 is stopped producing, obviously the process flow happening from process 1 is still continuing. There is no stop to that flow because you are driving the process 1 on the basis of the push system, which already has a planning horizon defined, and therefore there will be a pile up. Okay, because the process 2 is not able to absorb anymore and the process 1 is still sending the material, so there is going to be a pile up. So this is a natural consequence of a disbalance which will happen because of the defect of the process 2. Obviously in that system then you will have to really make sure that the process 2 comes to normalization within minimum possible time so that this pile up is reduced, etc. But whatever you are doing here is very, very wasteful. Obviously then another issue is that at the end of the process, supposing you have produced 30,000 parts based on the planning horizon, and supposing in between there is a need change or the aspiration change of the customer and the demand suddenly falls down, then what do you do with this finished product? So this is either all made shelved and the right marketing opportunity being initiated for selling them off, or in other words, if that doesn't happen, then the only other situation is that you have to scrap some of this product off, or maybe just retranslate that back into another aspiration or another need. So you'll have to make the additional work of disassembling things and trying to have some of the components to suffice. Normally the companies don't do that. Once the product is produced, they will either shelve it if not needed and then wait for an opportune time to give it to the customer. But then this by and large suggests a system where there is many chances of flaw or bottleneck as far as the intermediate processes are concerned, or as far as the customer need mapping or customer aspirations are concerned. Okay, so this is generally the disadvantage with the push based system which continued before the TPS or the Toyota production system came into the process, and in fact TPS for the first time showed that this push system can be completely converted into a lean pull system, where it would be the customer requirement that would be mapped at every stage, and the information would come based on that particular requirement. So you need not really overproduce, and if the expectation changes and there is a need map which is different from for certain time horizon, and then suddenly is able to change within that horizon to some other direction, obviously the production flow will also change in accordance with that, and there may be minimalistic stock at different levels because of that need change or need mapping change. So that's how a pull system would work out. So now here you have a finished product which is done by the customer in terms of a requirement, and this requirement now starts to go in the backward direction. You have maintained the stock in between all the processes 1, 2 and 3, so that you can address the process, and that's the reason why assembly lines, okay, they are brought in. That assemblies are basically having a work in process inventory which is semi complete, and the line would go at a certain rate of the expectation and aspiration of the customer. So therefore the customer has given a plan, okay, and based on that plan of his requirements or aspiration, the product information goes back to the process 3, which already has a semi finished inventory and is waiting for the customer order. Whenever the customer order comes, the process 3 finishes the particular work in process and sends it as a product to the customer, okay, and simultaneously orders for again some part from process 2, so that it can augment the vacancy or void created in the process 3, so on and so forth. So now what is happening is that the information about the requirements is really flowing in the backward direction, and the production is flowing in the forward direction, and there is a complete need mapping now. So wherever there is an aspiration change on a real time, you would be able to change this information flow so that exactly what is needed is delivered, okay, and then the processes are definitely made flexible enough so that they can suddenly change to this business pressure or business environment, and that's all about the design of the system, okay, in place. Obviously it cannot be really a real time change. There are limitations. The individual level processes have to be changed. It will take some time for changing the process also, but the whole idea is that can it be quickly arrested so that there is minimalistic pile up in between, okay, and that's how philosophically the system is designed, okay, and therefore you have a information flow in the backward direction and production flow in the forward direction, which represents the pull based system. So there are many advantages of a pull based system, and there are many modalities of a pull based system. The advantages I think I have enumerated a lot now. Now let us look at some of the basic engineering modalities associated with designing such a system. So the central tendency or the central requirement of such a system is the information flow, and the information flow happens through this particular item here, which is known as Kanban or visible record, which talks about how much material between what process to what process at what particular time, and what is the type of the material in one single go, okay. So there are normally two different kind of most commonly used Kanbans or cards, Kanban cards. One is called the withdrawal Kanban, okay, another is called the production Kanban, and I am going to now individually start designing the system with respect to the withdrawal Kanban and the production Kanban. So you can see that the primary function of a withdrawal Kanban is to pass the authorization for movement of parts from work center to another. Once it fetches the part from the preceding process and moves them to the subsequent process, it remains with them till the subsequent process has consumed the particular part, okay, and when the consumption has happened, only then the withdrawal Kanban has to travel back to the preceding process to fetch equal number of parts which have been consumed in the succeeding process, okay, and this cycle keeps on continuing. So Kanban card releasing the material to the next station consuming that material, and then releasing the Kanban card back to the previous station, and moment the previous station gets the card, it starts to produce that particular material and sends it ahead to the center 2 or the succeeding center, and the cycle of the card and the production flow keeps on continuing for a lean inventory maintenance between two stations. So with the withdrawal Kanban, it should have the following information. It should be typically what is the part number, what is the part name, what is the lot size, okay, and the routing process that is needed to fetch the part, and these all are given as a part of the information on the card. Let's describe how a Kanban card really looks like. So this is how a withdrawal Kanban looks like. You have raw materials and other part types used in manufacturing at the work center. You have the container capacity, which gives you number of parts. There's a part number which describes what the part is, and also it describes what is the preceding work center number and what is the stock location number for this particular work center number that this card has to go in. The production Kanban, on the other hand, is something whose main function is to release an order to the preceding process to build parts equal to the lot size specified on the card. Okay. If I just want to see what is the flow of the withdrawal and the production Kanban and their interactions, let us look at this particular case of two stations. One is the preceding stage PPS1 and the subsequent stage SPS2. So these are two stations, and there is a stocking area in between where there is some little bit stock to absorb the the flow irregularities between the subsequent stage and the preceding stage which may happen between. And so let us see that what part of the cycle does the withdrawal Kanban obey and what part of the cycle does the production Kanban obey. So if I look at, let's say, what is going to happen in the stacking area, let's say there is a full container F which has some kind of a withdrawal Kanban card given by this circular figure here, okay, and place. So the moment this withdrawal Kanban is put in this full container, the container moves ahead and the container goes all the way to the subsequent stage. Moment it comes to the subsequent stage, the container is to be used now by the operator in the subsequent stage, he will pick this card, this circular card, and keep it in a stacking bin at P2 location here. Okay. So the container is separate and the card has been kept at P2 location, and now the container is being used by the subsequent stage continuously. Okay. So now whenever the empty container comes out, let's say for example there has been some there was another container which was being partially used, or it was just about to get finished when this ordering was done by the operator through the withdrawal Kanban means. Okay, so in that case there may be some time delay and there may be some waiting period for this particular card, and whenever there is a bin which is empty at this station, this SPS2 station, this bin can be put with this P2 card and sent back as an empty container. So you can see that this P2 withdrawal Kanban is going along, traveling along this empty container all the way to the site E. So you have now an empty container here, okay, in this stacking area. So now there is a role of production Kanban will come into picture. So obviously there is a production Kanban card which is, so this replaced the card here that you can see, circular card which is the withdrawal Kanban, goes and fits into a full container. Okay, and obviously the full container has this this rectangular card that you can see. This card actually is changed back to the empty container, and this rectangular piece of card is called the production Kanban. Okay, so the circular is the withdrawal Kanban, and the rectangular is the production Kanban. So once I have said that there is a withdrawal and a production Kanban in place, so you are exchanging merely, the full container gets the withdrawal Kanban, so the circular moves up here and the rectangular Kanban comes down to the empty container, and the empty container comes back or gets transported back from the stacking area all the way to the preceding stage when this production Kanban which it had carried along is actually released, and there is the moment it arrives there is a production plan which comes into this preceding stage, there is material processing which starts happening, etc., and people start initiating the empty container and make it full. But before that happens, you ensure that there is some kind of a one bin or one lot in place which has already been produced, so that the rectangular card now can be fitted to that particular full bin or full container from the preceding stage, and the moment there is a rectangular card on it, the full container starts moving to the stocking area. Okay. And in the meantime, because you had this withdrawal Kanban circular card fitted on this full container would also start moving towards the subsequent stage. Okay. So therefore, the right side of the whole process from the stacking area to the subsequent stage as a cyclic flow of the circular card, that is the withdrawal Kanban, and the left side of this process from the preceding stage to the stacking area as a circular flow of the rectangular card, that is the production Kanban. So this is the production Kanban side, and this is the withdrawal Kanban side, and obviously this cyclic flow has to be maintained in a well balanced manner, and that will determine the size of the stacking area, or as a matter of fact how much minuscule stock can be kept at the preceding or the subsequent stage. So the overall behavior in this flow system is that the flow should be such that the container capacity, that is the intention of the JIT system, should be limited to one container. Okay. It is very difficult to achieve that kind of a capacity, but obviously the minimalistic approach would be a better idea. So if you have, instead of one, about 5 containers to do all this stock balancing job between the PPS1 and SPS2, you are very much there. So that is the essence of the lean manufacturing, and that is the way that this Kanban circulates. And now I would like to increasingly evaluate a ways and means based on a certain demand pattern or a forecasting pattern or whatever, how you can maintain this overall flow balance with minimalistic inventory at a certain level. Okay, so we'll try to estimate and do some problem examples how to actually calculate the number of Kanbans which would be flowing in a system to keep the system in active state. So with this, I would like to close on this particular module, and in the next module we'll probably do a little bit of mathematical analysis as to how to estimate this overall Kanban level. Thank you so much.